Many of our customers would love to say that their product is 100% effective against X virus. Is it possible to get 100% viral efficacy? And how different is 97% compared to 99.99%?
Yeah, that's a great question. We actually get that question relating the results of a test measured as percent reduction or also as log or logarithmic 10 reduction. And the range of that result relative to its effectiveness or performance. There's sort of two categories for the analysis of that information. One has to do with the reproducibility of the data or the statistical significance, and the other has to do with certain types of requirements that regulatory agencies might actually require a product to achieve. They're interrelated to some degree, but also to the degree of robustness of the result, the reproducibility, as I mentioned, of the result, and sort of the conditions for the testing and the variability that might be incorporated into those conditions of testing. So with respect to the first sort of category of information, anything less than typically 90%, and this is a general sort of framework for industrial types of tests, is not considered necessarily statistically significant. And that has to do with the variability, the inherent variability in measuring antimicrobials and microorganisms in these types of tests. So if it's less than 90%, it's either considered not statistically significant in terms of a demonstration of performance, or something that would probably be marginal when you go to reproduce the test. And so typically the recommendation, if you're looking at a result in that type of range, is to either retest, to reevaluate the product performance, maybe look at different parameters for the testing, such as the duration of the exposure time, the presence or absence of soiling, and so forth. The second category has to do more specifically with the requirements of a regulatory agency such as the EPA. The range is important because what they're looking for is a robust test result that, given the variability of the at-use conditions, so where the product is intended to be used, how it's intended to be used, and so forth, can have a dramatic impact on the overall performance. And so they're incorporating this target value to compensate or to have a safety factor associated with that product performance. So for example, in an EPA test where you're looking at very short duration exposure to a product, the product would be expected to have 99.9 or higher relative performance depending on the intended use. And what that value is indicating is that given the intended use, say in a public space where there's a lot of contact, it could be in a hospital setting, it could be in some other type of setting where you have a lot of traffic or foot traffic interacting with a surface, they expect that the material or the product that's treated would have performance in that environment regardless of the presence or absence of soiling, the presence of wiping, or other sorts of material sort of interactions that would affect its overall durability. And so they specify those levels of performance to compensate and sort of incorporate that consideration into that product test.
Our active ingredient didn't perform as anticipated. What are common things customers would do well to consider in these types of situations?
That's a great question. I mean, it's also a very common question because as you're developing and designing new products, the incorporation of these types of additives or ingredients can be complicated depending on the nature and the other ingredients incorporated into that product. So for example, one of the things you want to consider when you're adding an antimicrobial into a material is whether or not you're adding it into the bulk of the material, in which it would be present in the full cross section of the material if you were looking at it, from the standpoint of cutting the material or somehow abrading it, or if you're applying it into the coating of the material or on the material, which would allow for that antimicrobial to be mainly oriented near the surface of the material. In either case, you have to take into account how that material is adhered. So for example, if you're incorporating into the bulk, it has to be miscible or somehow compatible with that environment. So if it's a plastic, it would have to be compatible with that plastic in a way that both allows it to be retained and also to some degree present on the surface. And a lot of antimicrobials are either inorganic, such as silvers or zincs, and some are organic. And those different compositional properties make the material either more or less difficult to have fully dispersed into the bulk of the material, and therefore some may or may not be present in adequate amounts on the surface. And to make that more sort of direct, that analysis more direct or easily understandable, is if you were to apply as a coating, with a coating, at least you know that the material is present and on the surface of the product that you're actually testing or designing. And therefore, as you're analyzing it, you can better determine if it's maybe simply the concentration of the active ingredient that you're putting it into, or some other factor that may be affecting the performance and not associated with the way the material is incorporated into the product. The second sort of consideration you want to make when you're designing these materials is obviously the concentration. It's always advisable to look at different concentrations with respect to both the intended use and the label limits for those active ingredients. So the intended use has to do with how is that product going to be used and how effective will that antimicrobial be expected to be in that in-use environment. And then also from a regulatory standpoint, you want to know where the upper limit is for that particular intended use. That'll help guide the design cycle so that you can actually incorporate it at a higher level maybe than you would normally for the intended use of the product, but at least give you some guidance in terms of performance, what your overall best sort of case performance could be. And if you do that early on in the design cycle, you'll have a better understanding that could promote the design of the product more efficiently. Other than that, it typically has to do with compatibility. Compatibility of the chemistry, the manufacturing process. Different types of products have lots of issues associated with how it's manufactured, how it might be stored before it's incorporated into the product, the temperatures at which that product are formed or cured at. Those sorts of things always are a component in the actual efficacy of the active ingredient in those products, and it's something that the supplier of the active ingredient should be able to guide on, but ultimately it's going to be the manufacturer's product to deal with, and so those are features you're going to want to have some level of scrutiny on, or at least record keeping, so you can analyze them as problems arise. Yeah.
Excellent.